Imagine drifting in the far darkness beyond Mars, where sunlight is no more than a faint whisper against the cold. Space there is still. The temperatures drop so low that even thought itself feels frozen. And yet, in that frozen silence, something unexpected begins to stir. A small body of rock and ice, whispering through the dark, exhaling faint trails of vapor. Astronomers didn't believe it at first. They were used to comets sleeping until they came close to the warmth of the sun. That is the rule of our solar system. Comets awaken only when touched by light. But 3I Atlas, a visitor from another star system, broke that rule entirely. It began to breathe 40 kilograms of water every second, while still more than 3 times farther from the sun than Earth. Out there, where no warmth should reach, where water should remain locked as solid ice for eternity, it was flowing. The Swift Space Telescope first caught sight of this impossible behavior in early 2025. Swift wasn't built for comets. It was designed to hunt the violent flare of gamma-ray bursts, but its ultraviolet eyes happened to cross paths with something unusual, a faint, expanding cloud of hydroxyl molecules around a dim, moving point of light. Hydroxyl, OH, forms when sunlight breaks apart water molecules. Seeing that signature means water was just there, freshly vaporized, screaming as it tore away from the surface. When scientists ran the numbers, they stopped speaking for a moment. The rate of water loss was staggering, more than 1027 molecules every second, roughly equivalent to a car's mass in water vanishing into space every minute. It was not a trickle but a flood. Comets within our solar system, even the active ones, never behave this way at such distances. At that range, sunlight carries barely 1/10 of the warmth it has near Earth. Ice should be inert, frozen in perfect stillness, but 3I Atlas was alive with motion. Astronomers began to ask themselves, how? What hidden mechanism could make a comet release water where it should sleep in silence? Could it be harboring exotic forms of ice, amorphous hydrogen compounds, or crystalline mixtures that sublimate at lower temperatures than ordinary water? Was there residual heat trapped deep inside, a remnant of its formation in some ancient star system billions of years ago? Or could there be internal chemistry still reacting, quietly releasing energy across eons? The questions multiplied faster than the answers. The more telescopes pointed their mirrors at the interstellar visitor, the more the mystery deepened. Spectral readings showed not only water, but also faint traces of carbon dioxide, cyanide, and, most curiously, nickel. Nickel, shimmering green under ultraviolet light, appeared far stronger than anyone expected. Its spectral line glowed against the black, as if a message was being written in light for centuries. Humanity has looked at comets as omens, fiery messengers crossing the night sky, bringing change, fear, or renewal. But here was a comet that seemed to whisper from another epoch entirely. It didn't belong to our solar system, didn't obey our sun's gentle commands. It had traveled light years to be here, carrying secrets from a different cosmic neighborhood, a place shaped by other stars, other elements, other rules of chemistry itself. Astronomers labeled it simply 3I Atlas. It meant it was only the third confirmed interstellar object ever observed, after 1 Oumuamua and 2I Borisov. Atlas was the telescope system that discovered it, perched in Chile's high deserts, scanning the heavens each night for moving dots of light. But the name carried a strange poetry. Atlas, the titan who held up the sky. In the weeks after its discovery, something shifted in the way scientists spoke about comets. They began to describe 3I Atlas not as a passive relic, but as an active participant in the cosmic drama, a traveler that refused to sleep. On paper, its trajectory was clear. It was moving through the solar system on a hyperbolic path, an open curve that would never loop back. Once it swung around the sun, it would leave forever, returning to the deep interstellar night. Yet in that fleeting window it had already rewritten part of our understanding of how comets behave. Some astrophysicists proposed that it could be releasing trapped volatiles from microfractures caused by stress. Others suggested that solar radiation, even at that distance, might be interacting with unexpected compounds on its surface, compounds that absorb light differently, focusing heat in specific pockets, awakening frozen materials like tiny geysers beneath a crust. But the simplest truth was also the most haunting. We didn't know. In science, uncertainty is often viewed as a gap to be closed, but in astronomy, uncertainty is a kind of beauty. Every unanswered question becomes a window into something larger than our imagination. And 3i Atlas was a window, a mirror even, reflecting the limits of what we thought possible. As days turned into weeks, amateur astronomers joined the professional observatories in watching it. Through backyard telescopes, they described it as a faint smudge of light with a ghostly halo. No tail, no bright nucleus, just a pale green shimmer slowly moving against the background stars. That color, soft, otherworldly, would later become one of its signatures. It is easy to forget that comets are storytellers. They are the oldest witnesses of their star systems, frozen archives of chemistry from the time planets were born. In every grain of ice lies information about the temperature, pressure, and radiation that shaped it. So when one from another star drifts into ours, it's as if a messenger has crossed the galaxy carrying a letter written in a language we barely understand. Atlas's letter began with water, the simplest, most universal molecule we know now behaving impossibly. Each hydroxyl photon recorded by Swift was a word, each emission line a sentence written across the cosmic dark. And the story it told was astonishing, that the rules of our solar system are not the rules of the universe. If comets elsewhere can awaken in the cold, if they can breathe where ours cannot, then the boundaries of habitability, of chemistry, of planetary formation, stretch wider than we dared to imagine. Some nights, astronomers would leave their observatories long after midnight, the desert air biting at their breath. They'd look up at that faint green traveller and feel a sense of awe mixed with humility. Because for all our telescopes, all our equations, the cosmos had once again done what it always does, surprised us, and somewhere, perhaps millions of years ago under another sun entirely, this comet may have circled a world now gone, its oceans frozen, its sky long silent. Maybe, when that world perished, a fragment of it was cast into space, carrying the memory of alien weather, alien chemistry, alien storms, and now that fragment had come here. It wasn't just releasing water. It was releasing history. The breath of another star system was now mingling with ours, and though we could barely see it, the universe was speaking. All we had to do was listen. The first time astronomers saw the spectral line, they thought it was an error. A thin, bright streak glowing in green, unmistakably nickel. But something was missing. Twin iron was nowhere to be found. In the chemistry of comets, iron and nickel are inseparable. They form together in the same stellar forges, condense in the same grains, and are released together when heat awakens their metallic bonds. Where there is one, there should always be the other. It is one of the quiet constants of cosmic metallurgy, but 3i Atlas had chosen to break another rule. when Quito, the very large telescope in Chile, turned its sensitive instruments toward the interstellar wanderer, it recorded bright nickel emissions, blazing like emerald sparks against the void. Yet iron was either invisible or astonishingly faint. It's so faint it barely rose above the noise of the data. It was as if smoke had appeared without fire, as if the universe had decided to whisper in a different language altogether. Scientists double-checked the calibrations, cross-referenced the wavelengths, and even suspected atmospheric interference, but every test confirmed the same message. Nickel was shining, iron was not. And suddenly a quiet question began to echo across observatories. What kind of star system builds a comet like that? The answer, if there is one, lies deep in the history of element formation. Both iron and nickel are born in the hearts of dying stars. When a massive star collapses, its final breath, the supernova, fuses lighter elements into heavier ones, scattering them across space. Those fragments later gather into new stars, planets and comets, but not all supernovae are the same. Some produce more iron, others more nickel, and the exact balance depends on the type of explosion, the mass of the progenitor star, and the chemistry of the gas cloud that followed. If 3I Atlas truly came from thick disk of the Milky Way, the region populated by ancient stars billions of years older than our Sun, then its elemental proportions might bear the fingerprints of those early cosmic furnaces. The thick disk is a museum of the galaxy's past. Its stars are relics of an age when heavy elements were scarce, when the universe was still learning to make the materials of planets and life. If Atlas was born there, its abnormal nickel-to-iron ratio could be a time capsule from that primitive era. Yet not everyone was satisfied with that explanation. Some chemists proposed a more intimate cause, not stellar ancestry, but molecular structure on Earth. Certain nickel compounds, called nickel carbonyls, can vaporize at relatively low temperatures. They form when nickel binds with carbon monoxide, an extremely volatile gas common in young planetary systems. If Atlas formed in a region rich in carbon monoxide, nickel could have been trapped within these fragile molecules. As sunlight reached the comet, those molecules might have broken apart, releasing pure nickel vapor into the coma. Iron, meanwhile, would remain locked in heavier minerals, too dense to escape. Others pointed to the scars of deep time, interstellar radiation, cosmic rays, and ultraviolet bombardment could have slowly altered the comet's surface during its journey across the galaxy. Over millions of years, iron might have oxidized or sunk below a weathered crust, while nickel, more resistant to certain reactions, lingered near the surface. In that case, what we see glowing now could be just the comet's skin, chemically different from the untouched interior. There is also a more exotic theory, whispered among the more imaginative astrophysicists, that the high nickel content could be evidence of an unusual parent star, one enriched by a rare type of supernova that produces disproportionate amounts of nickel. If true, 3I Atlas might have been born in the debris of such an explosion, inheriting a metallic recipe not found anywhere near our Sun. Every element, every ratio, would then be a signature, the spectral handwriting of an ancient star long vanished into darkness. But there is something poetic about that idea, that when we observe a distant comet's green fire, we are not just seeing gas, but reading the autobiography of a dead sun. As 3I Atlas drew closer to the Sun, its spectral glow only intensified. Observers described it as if the comet was surrounded by a halo of jade light, pulsing gently against the void. The data showed something even stranger. The brightness wasn't scaling linearly with its distance to the Sun. It was growing faster than expected, as though each degree of warmth unlocked a deeper layer of its chemistry. To many, that behavior hinted at structure, stratified layers within the comet, each harboring different ices and metals. When one layer vaporized, it exposed another beneath it, triggering a cascade of reactions. It was chemistry as choreography, a slow, cosmic dance between sunlight and matter. And yet, for all its strange beauty, the nickel mystery remained unsolved. Each proposed model opened more questions than it closed. Why had no other comet ever shown such separation between metals so closely linked? Was it truly unique, or had we simply never looked closely enough before? Astronomers began re-examining older comet spectra from archives. Hale-Bopp, Hyakutake, even Borisov, searching for faint nickel lines that might have been overlooked. A few traces appeared, weak and uncertain, but nothing like the luminous pattern of 3I Atlas. Whatever was happening here seemed new. In quiet moments, between data sessions, some scientists confessed that the comet almost felt intentional, not because they believed in anything artificial, but because its behavior seemed to respond. To sunlight, to distance, to observation. It was as though the universe was performing a slow revelation, layer by layer, giving just enough mystery to keep us looking. The philosopher-astronomer Carl Sagan once wrote that to study the cosmos is to engage in a conversation with time itself. When we look at stars, we are reading ancient light. When we look at comets, we are reading the frozen remnants of creation. But 3I Atlas adds another voice to that conversation, one that speaks in the accent of another world, and that voice, carried in nickel's spectral glow, says something simple yet profound, that matter remembers. Each atom within that comet has lived through events beyond our imagining. The birth of stars, the collapse of worlds, the long drift between galaxies. It has witnessed silence older than Earth. Now, for the briefest moment, those atoms are illuminated again, letting us glimpse their memory through the prism of light. In that light, there is no chaos, no noise, only story. The story of a star that once burned, of a system that formed and died, of a traveler that carried a fragment of that fire across billions of years to arrive here, to let us see it one last time. And when that green fire fades into the black, what will remain is not confusion, but gratitude, because in a universe filled with silence, even a whisper of difference, a comet that shines with nickel alone is enough to remind us how varied, how alive and how ancient the cosmos truly is. For weeks, the Atlas drifted in silence, a faint emerald haze, a ghost adrift beyond Mars. And then, without warning, it changed. Astronomers watching through ground-based telescopes noticed it first. The coma, once pale and neutral, began to shimmer. The color deepened into green, not the soft pastel of ordinary comets, but a vivid, almost electric hue. It was as though the comet had inhaled light and was now exhaling life. At first, the shift was subtle, a trick of exposure time perhaps, or atmospheric refraction. But night after night, the transformation grew undeniable. The comet wasn't merely brightening, it was igniting. In our solar system, comets follow a predictable rhythm. As they approach the Sun, sunlight warms their surfaces, turning ice directly into gas, a process known as sublimation. The closer they get, the stronger the reaction. The pattern is smooth, gradual, almost mathematical. Twice as much sunlight, 4 times as much brightness. A gentle, geometric unfolding. But 3I Atlas refused that geometry. Its rise in brightness wasn't steady. It was explosive. Each small step closer to the Sun unleashed a burst of energy disproportionate to the increase in heat. This wasn't a linear awakening, it was a switch. Astronomers have a name for such behavior: superlinear activation. It means something inside the comet was crossing thresholds, layers of matter that remained dormant until a specific temperature or intensity of light flipped them on. One moment inert, the next alive. The first of these thresholds had been crossed far from the Sun, when it began releasing water at 3.5 astronomical units, where it should have slept. But now, as it drew closer, new materials joined the chorus. Cyanide, carbon dioxide, nickel. Each with its own spectral voice, each lighting a different color in the cosmic symphony. The green came from cyanide molecules fluorescing under ultraviolet radiation, mixed with the spectral lines of atomic nickel. Together they painted a glow that seemed unnatural, not because it defied physics, but because it felt almost deliberate. And then came the most haunting part. The comet's emissions didn't just increase, they began to pulse. Minute variations in brightness, rhythmic and recurring like the heartbeat of something stirring beneath the ice. No one knew what caused it. Could it be rotation? Perhaps jets of vapor erupting from fissures as the comet turned on its axis, exposing pockets of volatile ices one by one, or maybe internal fractures, pieces of crust splitting under thermal stress, exposing fresh reservoirs of frozen gases. Each crack, each fracture would release a sudden rush of vapor, a brief flare of light before the surface refroze. But there was another, subtler possibility, that the comet's coma wasn't uniform, that it was surrounded by countless microscopic ice grains, fragments torn from its surface and suspended in a thin mist. Each of those grains, floating free, could sublimate in its own time, like a million tiny comets orbiting the main body. As they warmed, each one released its own breath, adding to the comet's shimmering veil. In that model, 3I Atlas wasn't just one object, but a cloud of awakening matter, a diffuse organism made of countless parts, each responding individually to sunlight. The result was unpredictable, chaotic, and mesmerizing. It was also fragile. Comets are among the most delicate structures in the solar system. They are loosely bound aggregates, cosmic snowballs laced with dust and rock. When one region heats up faster than another, internal stresses build. And when those stresses surpass the comet's meager strength, it cracks. Sometimes it breaks apart completely, scattering into 1,000 smaller bodies. There was quiet, fear among the scientists watching. 3I Atlas that it might not survive its journey around the Sun. The same patterns of sudden brightening and outbursts had preceded the disintegration of other comets before: Ison in 2013, Atlas C 2019 Y4, and several smaller visitors lost to the Sun's gravity. But 3I Atlas was different. Its bursts were controlled, rhythmic, as though it had found a way to release its tension gradually instead of catastrophically. It flickered, flared, dimmed, yet held itself together. That resilience made it even more intriguing. Was there something in its structure, a binding agent, perhaps, or a crystalline form of ice unknown to our system, indeed, that made it stronger? Could its peculiar chemistry be a form of natural armor forged under alien conditions? Deep within observatories, researchers began running models of its composition. They proposed that its nucleus might contain multiple strata, outer layers of carbon dioxide and carbon monoxide ice, mid-layers rich in cyanide and organic polymers, and a deeper core dominated by water ice and silicate dust. As the sun's energy penetrated layer by layer, each stratum awakened at its own threshold, producing the stepwise eruptions astronomers were observing. It was like reading a thermal diary, each new flare revealing what the comet was made of and, by extension, where it came from. Meanwhile, artists and night sky photographers began capturing its image. In long exposures, the comet looked almost alive, a glowing green sphere with faint ripples streaming behind it, like breath in the cold. Its symmetry was uncanny, as if shaped by unseen hands. Online, people called it the breathing star. To many, it became a symbol of renewal, of distant life, of cosmic connection. And perhaps, in a way, they weren't wrong. When we look at such phenomena, we are not just seeing light, we are witnessing communication across time. Every photon leaving that comet travels billions of kilometers to reach our eyes. When it finally arrives, it brings not only information, but intimacy, a message written in chemistry, translated by physics and felt as wonder. In the green fire of 3I Atlas, scientists saw the history of alien matter awakening. Poets saw the pulse of the universe itself. Both interpretations are true, because both speak to something fundamental, that we are participants in the same cosmic dialogue, even when the words are incomprehensible. The comet's brightness reached its first peak unexpectedly, an order of magnitude higher than models predicted. Then just as quickly it steadied as though catching its breath. This pattern, sudden flare, soft plateau, gradual fade, repeated again and again, defying every simulation. It was as if the comet were teaching us patience. Every time we thought we understood it, it changed the rhythm, shifted the tempo, redefined the rules. Each pulse said, "You don't know me yet, keep watching." Through its unpredictable awakenings, 3I Atlas became a mirror for our own curiosity, the way we too awaken in bursts, learn in thresholds, expand in unexpected directions. The comet was a metaphor for discovery itself, fragile, luminous, prone to collapse, yet endlessly driven to release its light. In the end, its green glow was not just chemistry, it was character. And as it continued its journey inward, toward the domain of the inner planets, astronomers wondered what other switches might lie within. Would it reveal new elements? Would it erupt, fragment, or survive to tell more of its story? No one knew, but everyone was watching. Because somewhere in that slow unfolding of light and gas, there was something profoundly human. The will to continue shining, even when the cold says you shouldn't. There is a saying among astronomers, every orbit is a memory of where something has been. If you trace that memory far enough, you might touch the moment of its birth. Atlas carries such a memory, one written not in words, but in motion. When its trajectory was first mapped, the numbers startled even seasoned scientists. The path was not an ellipse, like planets or ordinary comets that loop faithfully around the sun. It was hyperbolic, an open curve that never closes, a line that visits once and then departs forever. That single fact told us something profound. This comet does not belong here. It came from elsewhere, from the deep between stars, and will never return. As astronomers traced its path backward through time, they began a kind of archaeology of motion. They combed through archival sky surveys, finding faint, forgotten specks of light that matched its future coordinates. Each recovered image, each rediscovered pixel, extended the comet's story further into the past. When the data was stitched together, a haunting picture emerged. 3 years before its discovery, 3I Atlas had already entered our solar system's outskirts, gliding quietly beyond Jupiter's realm. 6 years earlier, it was still 6.4 astronomical units away, already inbound but invisible. Before that, the void. Beyond the planets lies the heliopause, where the solar wind weakens and the sun's magnetic breath meets the interstellar medium. Cross that invisible line and you're adrift in galactic space, a place not of nothing, but of almost nothing. There, 3I Atlas had been traveling for millions, maybe billions of years, long before human eyes existed to see it. Where did that journey begin? The answer, astonishingly, may lie in the structure of the Milky Way itself. Our galaxy isn't uniform. It's layered like a cosmic sediment of time. The youngest, most metal-rich stars, like our Sun, dwell in what astronomers call the thin disk, a relatively flat plane that sparkles with new generations of stars. But beneath and above that plane lies the thick disk, a more ancient population of stars that formed when the galaxy was still young, turbulent, and poor in heavy elements. Those stars orbit the galactic center on paths that are tilted, elongated, even chaotic compared to ours. They are survivors of collisions, the remnants of early mergers when smaller proto-galaxies collided to build the Milky Way's current form. Their chemistry is older, their metallic content lower, their histories longer than our solar system by billions of years. When scientists modeled 3I Atlas's trajectory using data from the Gaia Space Observatory, they found a faint connection. Its motion through space seemed to align more with the thick disk's kinematics than the thin disks. That meant it could have been born in that ancient population from material forged when the galaxy itself was still young and raw. If true, then 3I Atlas is older than our Sun, perhaps much older. To put that in perspective, when this comet formed, there may have been no Earth, no planets in our system, not even a stable solar nebula. Somewhere, in the distant reaches of the early Milky Way, gas clouds swirled around a newborn star, condensing into icy bodies that would later be flung into the interstellar dark. And one of them, a small, unremarkable fragment, would one day drift for billions of years, crossing the void between stars, carrying within it the chemistry of that ancient age. Now that fragment passes before our eyes. The idea is both scientific and deeply poetic. It means the light we see from 3I Atlas tonight is not just light, it's a time capsule. The atoms evaporating from its surface were formed in a star that lived and died long before the sun ever rose. In a sense, we're watching galactic archaeology in real time. The composition supports that story. The comet's odd abundance of carbon dioxide, the strange nickel-to-iron ratio, the scarcity of silicate dust, all point to a low metallicity origin. In the early galaxy, heavy elements were rare. There wasn't much iron, magnesium, or silicon, but lighter volatiles like carbon, oxygen, and nitrogen were plentiful. Those were the ingredients 3I Atlas inherited. It is, quite literally, made of older matter. Every molecule on its surface carries the signature of that chemistry. Carbon monoxide and dioxide dominate because the environment that gave birth to them was warmer than the outer reaches of our solar nebula. Water, which forms only in cooler regions, became secondary. That's why 3I Atlas releases more CO2 than H2O. Its chemical DNA reflects the conditions of a star system that had its own rules. And yet those alien conditions created something strangely familiar. When astronomers talk about interstellar comets, they often mention Y Oumuamua and 2I Borisov, the two that came before. Oumuamua was silent, barren, almost lifeless, a rock tumbling through space, dry as bone. Borisov, by contrast, behaved much like our comets, emitting water and dust in the expected ratios. But 3I Atlas? It sits between them like a bridge. It's active, yes, but in a way that defies the norms of both. It's as though the galaxy is showing us its evolutionary stages, a triad of wanderers, each carrying a different dialect of cosmic language. Some researchers have even suggested that interstellar objects like these might be the driftwood of galactic evolution. The debris left behind when planetary systems form, collide, and die. Each one carries clues about the diversity of planetary chemistry across the Milky Way. And if that's true, then 3I Atlas is not merely an anomaly. It's evidence, a sample from a time and place we could never visit. Imagine for a moment what that means. If this comet formed 7 or 8 billion years ago, then the ice now evaporating into space may contain information about how early star systems cooled, how they formed planets, how they lost them. Each outcast molecule is a record of that process, escaping into our instruments for a brief, luminous moment before vanishing forever. In a way, 3I Atlas is teaching us about the galactic past the same way tree rings tell us about seasons long gone, but instead of wood, its layers are ice and dust. Instead of years, they record epoch. And as it moves, those layers peel away, revealing one era after another, the chemistry of its youth, the radiation scars of interstellar travel, the warmth of a new star it will never know. Astronomers often describe such objects as messengers, but perhaps it is more accurate to call them echoes. They don't speak, they resonate. They carry within them the frequencies of forgotten places, and when sunlight touches them, those frequencies turn into light. It's strange to think of time as something that can move, that can literally pass before your eyes in the form of a green, glowing cloud. But that's what's happening. We are witnessing the motion of an ancient memory, and that memory doesn't end with its origin. The comet's hyperbolic path ensures it will leave us again, continuing outward toward another star, another darkness. Perhaps billions of years from now, it will drift through another planetary system. Maybe beings there, whoever they are, will look up and see it as a faint visitor, just as we do now, and wonder where it came from. Maybe they'll call it something else. Maybe they'll think it's theirs. But the truth will be the same. It belongs to no one. It is a citizen of the galaxy, carrying stories written in dust and ice, told only when it passes through light every so often. A question surfaces among scientists and dreamers alike. What if these interstellar comets are not random? What if they are the galaxy's natural communication network, slow, unintentional messengers drifting from system to system, sharing chemistry, spreading seeds of molecules that one day might become life? That idea, known as panspermia, remains unproven. But standing under the night sky, watching that glowing thread of green drifting through blackness, it doesn't feel impossible, because maybe the universe doesn't send words or signals. Maybe it sends comets. Maybe every few million years, one of them crosses into a new solar system, releasing its ancient contents, stirring new reactions, passing the spark of its history onward, like a traveller lighting torches in the dark, one world at a time, and as 3i Atlas continues its slow, graceful arc around our sun, shedding pieces of itself into our cosmic sea, it becomes part of our story too. Its dust may settle in our atmosphere, its molecules may join ours in some quiet way, its past becomes part of our present. We might never know the exact coordinates of its birthplace, but we know its direction. Backward in time, outward in space, toward the first chapters of our galaxy's long, unfinished book. Every time we look at it, we are reading that book, a story of formation, survival, and infinite travel, and like all great stories, it ends where it began, in silence, in motion, and in the unending search for meaning across time. Every comet is a recipe. Each one carries its own list of ingredients. Frozen molecules, trapped gases, grains of dust, a record of what the universe was cooking when it formed. But 3i Atlas, that recipe doesn't match any we've seen before. When astronomers began to analyze its emissions more closely, the numbers refused to make sense. In most comets within our solar system, water dominates the mix. It is the heartbeat of cometary life, the main driver of activity. The first molecule to wake when sunlight calls, carbon dioxide, carbon monoxide and other volatiles are there too. But they play supporting roles. Usually, water makes up over 80% of what a comet exhales. I Atlas reversed that balance entirely. 95% of its outgassed volatiles appeared to be carbon dioxide. Water was the minority. That ratio, CO2 to H2O, was not just unusual. It was backward. It was like finding a planet where oceans are made of air and the sky made of ice. To scientists, this imbalance meant only one thing. The place where 3i Atlas formed was profoundly different from the cradle of our solar system. The chemistry of its birth was alien in the purest sense, born under different pressures, temperatures, and radiation fields. Carbon dioxide condenses into ice at warmer temperatures than water does, so if Atlas is rich in CO2 but poor in H2O, it likely formed in a region closer to its parent star, a place too warm for much water to freeze, but just cool enough for carbon dioxide to solidify. That means this interstellar traveler might once have circled a sun-like star in its inner system, perhaps not far from where Venus or Earth would orbit in ours, but something disrupted that quiet orbit, something powerful enough to fling it into the void. Maybe the giant planets of that system migrated, like ours once did, tossing smaller bodies outward like stones skipping off a pond. Or maybe a passing star's gravity tugged it loose. Whatever the cause, 3i Atlas was exiled, cast out into interstellar night, carrying with it the frozen chemistry of a lost world. Now as it crosses our solar system, those ancient materials are waking for the first time in billions of years. What makes this more fascinating is not only what Atlas contains, but when its molecules choose to appear. In most comets, water, cyanide, and carbon dioxide tend to sublimate together. They are companions releasing gas at similar temperatures, but in 3i Atlas, cyanide appeared later, after water had already begun to fade. That delay puzzled researchers. Cyanide, or CN, is one of the most chemically important molecules in prebiotic chemistry, the kind of molecule that can lead to amino acids under the right conditions. So why was it buried deeper? Perhaps, scientists suggested, it was trapped within more complex organic structures, polymers of carbon and nitrogen that required higher temperatures to break down. If so, then 3I Atlas might contain layers of organic chemistry far more intricate than any comet we've studied before. And that possibility opened a door into an ancient question. Could life, or at least its building blocks, travel through space? The idea, called panspermia, has haunted scientific imagination for centuries. It proposes that the seeds of life might not have begun on any one planet, but drifted between worlds, carried by comets and asteroids. If true, life on Earth may not have started here at all. It might be part of a grander cosmic lineage, passed along like a flame. Of course, this remains speculation. Radiation in interstellar space is brutal. High-energy particles shred complex molecules. Ultraviolet light disintegrates even amino acids. For life to survive such a journey, it would need shielding, deep layers of ice or rock to protect it. And yet, some simple molecules can endure. Cyanides, formaldehydes, and certain hydrocarbons have been detected in the tails of ordinary comets. In laboratory simulations, these molecules can combine to form sugars and nucleobases, the scaffolding of DNA, under energy input by the Atlas, with its strange surplus of carbon dioxide and cyanide, may be a natural test case for that process, an interstellar chemistry experiment billions of years in the making. If any place could preserve those molecular fossils, it's the interior of a comet inside sunlight never reaches. The temperatures hover near absolute zero, halting reactions for eons. A molecule trapped there could sleep longer than entire civilizations, waiting only for the warmth of another star to stir it awake. And that is what's happening now. When sunlight touches 3I Atlas, it is performing an act both destructive and revelatory. It tears apart ancient molecules, but in doing so lets us see what they were. Spectral linings, faint barcodes in the light, reveal not just chemistry, but history. They tell us what elements were abundant in its home system, what temperatures it once knew, and how it has changed through cosmic time. The cyanide line, for example, glows vividly in the blue-green part of the spectrum, giving the comet its ghostly hue. That color is the visual echo of an ancient molecular vibration. The same vibration that, under gentler conditions, might have once danced inside a living cell. It is humbling to realize that the same bonds, carbon to nitrogen, carbon to oxygen, are universal. They existed before life and will persist after it. What we call biology may just be chemistry playing a slower, more complex song, and 3I Atlas is humming that tune in the dark. Some observers have called it a molecular message in motion, not a message written intentionally, but one inherited, a signature of the early galaxy, preserved and now delivered by accident to our corner of space. In that sense, every interstellar comet is a form of communication, not between civilizations, but between epochs. Each one carries a different dialect of matter, and when we intercept them, we're not just collecting data, we're eavesdropping on the conversations of the cosmos. There's a quiet beauty in this idea, that the universe is not silent. It simply speaks in chemistry. Every molecule is a syllable, every spectrum a sentence, every comet a paragraph in the autobiography of creation. Some astronomers have even imagined the future, missions that might one day intercept a visitor like 3I Atlas, spacecraft designed to match its velocity, land and take samples before it vanishes into the dark again. It would be the most ambitious archaeological dig imaginable, an excavation across time itself. The challenges are immense. Interstellar comets move at tens of kilometers per second, Catching one is like trying to land on a bullet. But if we succeed, the reward would be beyond measure real. Physical material from another star system, a tangible fragment of the galaxy's distant past. In the meantime, all we can do is watch, measure, and listen. We analyze the light, compare ratios, and try to translate what 3i Atlas is saying through its chemistry. And though it tells us nothing directly, its silence is eloquent. It tells us that carbon and oxygen, the very atoms that build our breath and our bones, are also the storytellers of the cosmos. That life, whatever it means, wherever it arises, where it is written in the same alphabet everywhere, C, N, O, H, the language of the stars themselves. In the great scale of the galaxy, comets like 3i Atlas are the couriers of that language. They drift, they wander, they occasionally visit new worlds, leaving trails of molecules behind, faint signatures that might someday meet the right chemistry, the right heat, the right chance, and bloom into life again. It may not be purpose, it may not even be chance, it might simply be nature, doing what it always does, spreading possibility. As we watch 3i Atlas vent its ancient breath into our solar system, we are witnessing that possibility unfold in real time, not as an experiment in a lab, but as an event written in the stars long before our species existed. Maybe, long after it has gone, its dust will drift into our upper atmosphere, mingle with Earth's winds, dissolve into rain, settle into oceans, and maybe, in some infinitesimal way, a fragment of that interstellar chemistry will join the endless circulation of our planet. The air we breathe, the water we drink, the soil that grows our food. If so, then 3i Atlas won't just have passed by us, it will have joined us. The messenger will have delivered its message, not in words, but in atoms. And maybe that's how the universe truly speaks, quietly, invisibly, molecule by molecule, across the dark. When 3i Atlas first appeared in the sky, it wasn't found by a vast space agency or a billion-dollar satellite. It was found by people, ordinary people, scattered across continents, peering through telescopes in backyards, scrolling through lines of data on glowing screens. They call them citizen scientists, but that phrase doesn't capture what they truly are. They are listeners, watchers, the quiet bridge between wonder and understanding. Astronomy has always been a science of patience. You can't rush the sky, you wait for clouds to clear, for telescopes to calibrate, for the slow dance of light across time, and in that waiting, amateurs and professionals meet as equals. In March 2025, while most of the world slept, a volunteer in the Radio Galaxy Zoo project noticed something strange in a data map from the Low Frequency Array LOFAR telescope in Europe. A faint ring, then another. Two perfect circles of radio emission intersecting like the infinity symbol, glowing gently against the cosmic background. He tagged the image. Weird pattern here? That simple comment started a chain reaction. Within days, professional astronomers had confirmed it. The largest and most distant odd radio circles, or ORCs, ever discovered. No one knows what they are. They could be shock waves from ancient galactic explosions, or vast magnetic bubbles blown by black holes. But one thing was certain: a volunteer, not an algorithm, had seen it first. That's the thing about data. Machines can process it faster, but they can't wonder. They don't feel the shiver of recognition when they stumble upon something that shouldn't exist. The human eye, flawed and intuitive, still catches patterns no software anticipates. And as the discovery of those strange circles spread, a quiet question rippled through the astronomy community. If amateurs could find radio ghosts millions of light-years away, what else might they find closer to home? What if someone, somewhere, had already noticed something unusual about 3i Atlas before the professionals did? After all, the data is public. Swift's ultraviolet measurements, ground-based spectra, even comet brightness logs, all open for anyone to explore. All it takes is curiosity and a few sleepless nights. It's happened before, amateur. Astronomers have discovered supernovae before observatories could react. They've spotted asteroids that later became mission targets. They've even tracked changing light curves of variable stars, building databases that NASA itself uses. Their secret isn't equipment, it's attention. That rare, unprofitable act of simply looking carefully. In an age of automation, attention has become the last human frontier. And so, as 3i Atlas grew brighter, a quiet network of skywatchers began to follow it from their balconies and gardens. They shared photos, compared notes, argued about filters and exposure, times. Each frame they captured added another piece to the story. Some images showed delicate tails invisible to larger telescopes, faint fans of light shaped by solar wind. Others caught the pulse of brightness no one could quite explain. A few even noticed that the comet seemed to breathe in cycles, its luminosity rising and falling over hours. It might have been rotational modulation, or perhaps the atmosphere of the comet itself shifting under sunlight. Either way, these observations helped professionals refine their models. It's a strange, beautiful symmetry, the universe revealing itself to both million-dollar observatories and backyard telescopes at once. But this collaboration isn't always smooth. Between amateurs and professionals, there's tension, a quiet line drawn by training, by hierarchy, by fear of error. Some scientists worry that too much public participation means too many false positives, too many hopeful eyes misreading noise as signal. And yet, without those eyes, entire discoveries would vanish into the flood of unprocessed data. The Vera C. Rubin Observatory, set to scan the entire southern sky every few nights, will produce 15 terabytes of images per night. No single team can inspect all of that. Even the best algorithms will miss things that look too weird. That's where human intuition still reigns, where imagination becomes a kind of scientific instrument somewhere out there right now. Another 3i Atlas could be crossing into the solar system, faint, unnoticed, leaving only a few pixels in an automated survey. It might take a volunteer's curiosity to find it, to give it a name, to let it speak. There's something poetic about that, but the idea that the universe relies on our attention to exist in our awareness. If no one notices, the event still happens, but it remains mute. The act of observation gives it meaning, turns raw physics into story. In that sense, citizen science isn't just participation, it's communion, a shared act of wonder. Every time a volunteer logs into a database to tag galaxies or scrolls through images looking for odd shapes, they are continuing the oldest human tradition, storytelling through discovery. They are listening for the universe's next sentence, and 3 Atlas has given them plenty to hear. There are forums now where amateurs discuss the comet's behavior like poets and physicists at once. They trade data points and metaphors interchangeably. One person describes the comet's green glow as like breathing. Underwater, another calls its color the sound of nickel turning to music science. And art intertwine effortlessly in those late-night threads. Because for many of them, the comet isn't just an object. It's a mirror reflecting what it means to care about the unknown. One volunteer wrote, "It feels like watching a messenger from a civilization that doesn't know it's communicating." That line spread across social media, translated into a dozen languages, quoted by newspapers and astronomers alike, and maybe that's the truest sentence about 3i Atlas yet. It is communication, not intentional, but profound. In its strange chemistry and unpredictable light, we see the essence of science itself, messages from nature, waiting for interpretation. Machines might collect the data, but it's humans, fragile, imaginative, imperfect humans, who give that data meaning. Sometimes, the greatest discoveries aren't measured in numbers, but in moments. A person alone at midnight, their telescope humming softly, the faint smear of green on a camera sensor, the realization that they are seeing something from another star. For a brief instant, they become part of the experiment, part of the story, part of the cosmos observing itself. And then morning comes. The comet fades into sunlight, invisible again, leaving behind only the record, images, notes, a digital trace of collective wonder. But even as it vanishes from view, it lingers in human thought, a question, a dream. A reminder that knowledge is not just something we acquire, it's something we share. If the universe is a grand orchestra of motion and light, then citizen scientists are the quiet listeners in the back row, catching the subtle harmonics the machines miss. Without them, the melody would be incomplete, so perhaps when 3i Atlas leaves us, when it fades beyond Neptune, back into the silence between stars, it will not disappear entirely. It will continue to live in the minds of those who noticed. Every observation, every tagged image, every breathless "I saw it" becomes part of its legacy. A chorus of human voices woven into the fabric of cosmic history. Because the truth is, the universe doesn't just belong to those who study it, it belongs to everyone who looks up. And maybe that's the quiet miracle of 3i Atlas. Not the chemistry, not the green fire, not even its ancient origin, but the way it made strangers on distant continents lift their eyes to the same point of light and whisper the same word. Beautiful. October skies have always had a way of stirring imagination. Something about that season, the cooling air, the sharpened stars, and seems to invite meaning into every glint of light. And October 2025 was no exception. As 3i Atlas glided across the heavens, two other worlds joined its stage. Mercury, the innermost planet, was shining bright after sunset, visible to the naked eye, a tiny bead of gold hovering above the horizon, and further away, the dwarf planet Ceres reached opposition, perfectly aligned with Earth and the Sun, glowing faintly in the dark sea of the asteroid belt. To astronomers, it was a coincidence. To others, it was a pattern, a celestial conversation. Social media lit up with speculation. Posts and videos connected dots that weren't meant to connect. Mercury, the messenger of the gods. Ceres, the mother of harvests. And now a comet, green as awakening spring, tearing across the black. Surely, they said, this alignment meant something. 3 symbols, one user wrote, a cosmic signal. Another called it the triad of renewal, and soon the whispers grew into theories. Some said the planets were calling to the comet, that gravitational harmonies had triggered its awakening. that its chemistry responded to unseen frequencies. Others went further, weaving numerology into orbital mechanics, claiming secret alignments that echoed ancient calendars or forgotten prophecies. It was beautiful in a way, not the claims themselves, but the impulse behind them, the need to find shape in the chaos, to turn randomness into story. Humans are pattern-seeking creatures. It's what kept our ancestors alive, recognizing constellations in the stars, tracking the moon's rhythm. Noticing when seasons shifted, we learned to see patterns because the cost of missing one was survival itself. But that same instinct now turns toward the infinite sky, searching not for food or safety, but for meaning, and sometimes meaning appears where there is only coincidence. There's a word for that, pareidolia. It's the mind's quiet trick. Seeing faces in clouds, hearing whispers in static, reading design into noise. It's not foolishness, it's evolution. So when Mercury, Ceres, and a glowing green comet shared the same month in our skies, our collective imagination did what it has always done. It dreamed. It's not the first time. In 1910, when Halley's comet returned, newspapers printed warnings that its tail contained cyanogen, a deadly gas. People bought gas masks, sealed their windows, and prayed. Some even believed the comet would poison the world. Of course, nothing happened. The tail's gas was so thin it could not have harmed a single breath, but fear had already filled the space that science could not yet explain. In that fear and fascination lies a strange truth about our species. We would rather live in a world full of intention than in one ruled by chance. Coincidences comfort us because they feel like messages. They let us believe that events are linked, that our lives are part of a grand pattern written in the stars, and so, when people saw Three-Eye Atlas glowing green while Mercury and Ceres shone together, they didn't see orbits and physics. They saw story. To them, it wasn't coincidence. It was choreography. Yet if you strip away the poetry, the reality remains serenely indifferent. Mercury's orbit is fast and frequent. It aligns with Earth several times a year. Ceres, too, reaches opposition annually, a rhythm older than humanity. The chances of both events overlapping with the appearance of a comet are not rare, just unnoticed. Still, the story was irresistible because deep down, we all want the universe to look back at us. That desire has echoed through every age. When ancient people saw comets, they imagined omens of war or change. When telescopes grew stronger, we replaced gods with science. But the longing stayed the same. We still hope the sky is speaking, and perhaps, in its own way it is, not through deliberate signs, but through the language of possibility, the way random alignments remind us that even coincidences can be beautiful. When people shared those viral images of Mercury, Ceres, and Three-Eye Atlas, they weren't just chasing mystery, they were participating in something older than civilization, the need to make sense of wonder. There's a paradox hidden in that impulse. The more data we have, the more we crave narrative, the more precisely we measure the cosmos, the more we yearn for poetry. Because knowledge fills our minds, but story fills our souls. And maybe that's why even scientists sometimes smile at these coincidences, not because they believe them, but because they recognize the poetry in our longing. In a quiet lecture hall one evening, an astronomer said softly, "Mercury didn't wake the comet, But if that thought makes someone look up, maybe it doesn't matter. He wasn't mocking. He was acknowledging something tender, that curiosity, even when misguided, is still sacred. The real danger, though, begins when wonder hardens into certainty, when coincidence becomes conspiracy, when imagination, untethered from humility, claims truth as its own. After 3i Atlas became a viral phenomenon, a small wave of misinformation followed. Claims that NASA was hiding data, that the comet's orbit was shifting unnaturally, that governments were silencing astronomers, none of it true, of course. But truth spreads slower than myth, and the algorithms that rule our digital age reward intensity over accuracy. The irony is almost cosmic. The same technology that lets us explore the universe with unprecedented clarity also amplifies our confusion about it. We have built machines that can detect galaxies billions of light-years away, yet struggle to detect our own biases. But even in that chaos, there is beauty. Because confusion means curiosity hasn't died. It means we still care enough to ask, even if we sometimes ask the wrong questions. If you step back, wander far enough to see the patterns of human thought as you would constellations, you might realize something profound. We are all doing what comets do, drifting through darkness, seeking light, leaving trails of meaning behind us. Our myths are the vapor we shed while orbiting understanding. And just like 3i Atlas, we glow brightest when we are closest to the warmth of discovery. So perhaps instead of mocking the myths, we should listen to what they reveal about us. Our hunger for connection, our terror of insignificance, our refusal to accept randomness as the final word. Science doesn't exist to erase that hunger. It exists to feed it, to turn vague longing into illuminated knowledge. The night sky doesn't send us coded messages, but it does send us opportunities, chances to wonder, to misinterpret, to learn, to begin again. And if Mercury, Ceres, and an ancient interstellar traveler happened to align in October 2025, maybe that coincidence was just the universe's quiet reminder. That meaning is not something we find in the stars, it's something we create, and then reflect back into them. There are mysteries that shout, and there are mysteries that whisper, but sometimes the strangest kind of mystery is silence itself. October 8th, 2025. A spacecraft rises through the morning haze of West Texas. 6 passengers, 11 minutes, 1 suborbital flight, Blue Origin mission NS-36, a success, according to every official report, and yet no one seemed to notice. For years, each Blue Origin launch had been a spectacle. Live streams, hashtags, celebrity guests, replay clips across the world. But this time, it was different. There were no trending videos, no viral excitement, no post-flight interviews. The capsule landed, the passengers walked out, and the world moved on in minutes. A few journalists wrote brief mentions. A press release appeared online, time-stamped, factual, dry. And then, nothing. That absence of noise became louder than any announcement could be. In the quiet corners of the internet, people began to ask the kind of questions silence always invites. Why haven't we seen cabin footage? Why did one of the passengers remain anonymous until after landing? Why does a routine flight feel like a vanishing act? Speculation bloomed. Some thought the video feed had failed. Others imagined something more deliberate. A withheld recording, a cover-up, or something stranger. None of it had evidence, but in an era where every event is endlessly documented, the lack of images feels like a ghost. We have grown so used to proof that absence itself now feels suspicious. Perhaps that's the truest sign of our times, that we no longer fear what is hidden, we fear what is quiet. It wasn't always like this. Half a year earlier, in April 2025, another Blue Origin mission had dominated the internet. That flight carried celebrities, musicians, journalists, icons, the kind of faces that turn spaceflight into entertainment. But within hours, it became something else, a conspiracy carnival. Millions of viewers dissected every frame, every reflection on the capsule window. They claimed the footage was fake, that hair didn't float right, that the sky outside looked too still. Experts explained that microgravity behaves unpredictably, that the lighting varied, that cameras distort perspective. But it didn't matter. Once disbelief takes root, truth struggles to catch up, and so by October, perhaps Blue Origin had learned something unintended. Sometimes the only way to escape noise is through silence. But silence is not empty. It echoes. When no one speaks, imagination fills the void. It asks questions, not because answers exist, but because uncertainty demands company. We live in an age where information moves faster than reflection. Every second births an opinion. Every absence becomes a canvas for projection. A missing video, proof of deception, a delay in communication, evidence of control. Our species has evolved from seeing faces in clouds to seeing conspiracies in data gaps. Pareidolia has migrated from the sky to the screen, and perhaps that's why this story belongs here, among tales of comets and cosmic travelers, because it's the same instinct and the same human need to make patterns out of shadows, whether it's Mercury aligning with Ceres or a silent spacecraft returning to Earth. We crave narrative, we need meaning, even in nothingness. The philosopher Hannah Arendt once wrote that the most radical form of power is that which can afford to be silent. But power here isn't only political, it's emotional. To withhold noise in a noisy world is to provoke thought. Maybe the quiet surrounding mission NS-36 was not conspiracy, but exhaustion, a collective fatigue. The recognition that space tourism, once miraculous, had become routine, that even a flight beyond Earth's boundary could no longer compete with the noise of the internet. If that's true, then the silence wasn't suspicious, it was symbolic. It told us that awe, too, has a half-life. When the first humans went to space, silence was sacred, the kind of silence astronauts described as overwhelming, spiritual, infinite. You could see the curve of the Earth and feel small enough to vanish into it. Now, silence feels like a glitch, a missing upload, an error, an oversight. What a strange reversal. Once we stared at the sky, longing for sound. Now we stare at our screens, uneasy when it stops, and yet silence has always been part of the universe's vocabulary. Stars die quietly. Nebulae bloom without a sound. Even comets, like Three-Eye Atlas, sing only through light, not through voice. Maybe the Blue Origin silence was just another echo of that cosmic truth, that not everything remarkable needs to be witnessed to be real. We have grown accustomed to verification, to proof. But reality doesn't depend on our attention. The comet doesn't care if we believe in its green glow. The rocket doesn't need applause to have touched the edge of space. Still, the mystery remains fascinating. not because something was hidden, but because it revealed how fragile our trust has become. Trust, once broken, doesn't return easily. It drifts like debris, circling truth, never quite docking. In that sense, silence becomes a mirror. It reflects the stories we project onto it, our fears, our doubts, our need for clarity, and those stories, like the faint tail of a comet, say more about us than about the object itself. For some, the lack of footage will always be proof that something went wrong. For others, it's a reminder that not every moment must be shared. Both interpretations are human, two ways of confronting the vastness of unknowing. When you think about it, silence is the original mystery of space. Every spacecraft, every astronaut, every comet we've ever studied moves through a soundless ocean. No echoes, no waves, just the soft hum of radiation and thought. Maybe that's why we find quiet so unsettling. Because in it, we glimpse the universe as it truly is, indifferent, immense, and perfectly still. If there's a lesson in the muted aftermath of NS-36, it's this. Not all knowledge announces itself. Some truths arrive softly. Some arrive wordless. Just as 3i Atlas teaches us about the chemistry of creation through a silent stream of light, so too does this moment remind us that discovery often hides in the quiet places between noise. Perhaps when future historians look back on our time, they'll see that the real revolution wasn't how far we traveled into space, but how we learned to listen to silence again. Because somewhere above those clouds, above the noise of speculation, 6 people looked down at Earth, a blue sphere suspended in nothing. For 11 minutes, they floated in pure stillness. They didn't need cameras or proof. They were part of the silence itself. And that, in the end, may be the most extraordinary truth of all. Every age of discovery begins with confusion. The universe never gives us answers directly, only puzzles dressed as light. A century ago, it was Mars. Decades later, pulsars, then came quasars, black holes, exoplanets. Each time we thought we'd reached the edge of mystery, the cosmos simply whispered, "Look again," and so, here we are, once more caught between awe and uncertainty, staring at another enigma that refuses to fit. Atlas is only the 3rd confirmed interstellar object ever seen. Before it came Oumuamua, the silent, tumbling fragment that entered our system in 2017. It moved too fast, spun too strangely, reflected light in ways that baffled every model. It showed no tail, no gas, no ordinary signature of a comet, and yet it accelerated slightly, as though pushed by some invisible force. Some said it was a shard of rock shaped by physics. Others dared to wonder if it was technology, a sail adrift from an ancient civilization. Then came 2I Borisov, discovered in 2019, bright, icy, beautifully normal. It behaved like the comets we know, obeying the familiar chemistry of water, dust, and carbon monoxide. It was comfortingly ordinary, proof that other systems make the same kind of mess as ours. And then, as if the universe was setting up a trilogy, came 3i Atlas, not silent like Oumuamua, not predictable like Borisov, but something in between, lively, volatile, impossible to categorize. 3 visitors. 3 chapters of a story that no one wrote, but everyone is reading. When Oumuamua arrived, we projected our curiosity onto it, our dreams of contact, our fear of isolation. When Borisov appeared, we projected relief. the comfort that the cosmos was comprehensible again. And now, with 3i Atlas, we project something else, our longing for meaning in chaos, because every anomaly, every unexplained behavior becomes a mirror. We don't just study it, we see ourselves in it. Oumuamua's silence reflected our loneliness. Borisov's familiarity reflected our need for order. 3i Atlas's defiance reflects our restlessness, our refusal to accept limits. There's something deeply human about this pattern. When we encounter the unknown, we first imagine it's intelligent. If it isn't, we make it poetic, and when it still resists our comprehension, we turn it into philosophy. Maybe that's why the language we use to describe these objects always drifts toward emotions. We say, the comet breathes, wakes, remembers. It's not just metaphor, it's empathy. We give the cosmos feelings so we can understand our own. But here's the strange paradox. As science advances, mystery doesn't shrink, it expands. The more precisely we measure, the more anomalies appear. Our instruments grow sharper, our data more detailed, but the horizon of confusion only widens. It's as if the universe were an infinite coastline. Every step closer reveals more intricate patterns of sand, each grain a new question. And that's what 3i Atlas truly is. One grain of cosmic sand magnified until it becomes a cathedral of questions. Why does it release water where no warmth exists? Why does nickel shine without iron? Why does its color pulse as though alive? Each answer we propose births 3 new mysteries, but this isn't failure. It's progress in disguise. Every revolution in science began as an embarrassment and an observation that refused to behave. When stars didn't orbit Earth, we built a new universe. When light bent around gravity, we built a new physics. When comets from other stars refused to follow our chemistry, maybe we're building a new understanding of life itself. Some scientists quietly suggest that studying these interstellar objects is like listening to the galaxy's autobiography, each one a single sentence in a billion-page book. The only problem is, we've read 3 sentences so far, and yet, even those 3 sentences already hint at astonishing diversity. One object dry, another icy, another strange and luminous. It's as though the galaxy itself was saying, there is no single recipe for creation. That realization changes everything. Because if planetary systems vary so wildly, then the chemistry that gives rise to life might not be rare at all. It might be inevitable, a consequence of diversity, not coincidence. Imagine billions of star systems, each cooking its own version of organic soup, each sending tiny frozen ambassadors drifting through space. Some will dissolve into dust, some will fall into stars, and some, like 3i Atlas, will wander long enough to reach us, carrying chemical whispers of what else might be possible. Perhaps life itself is not a local accident, but a galactic conversation, and we are only now learning to listen. But to listen well, we must be honest about what we hear and what we imagine. Throughout history, every unexplained light in the sky has tempted us to fill it with hope. Meteors became messengers, eclipses became warnings, comets became omens. Now, anomalies become aliens, data gaps become cover-ups, silence becomes signal. We haven't changed much, only our vocabulary has, and yet there's a certain grace in that continuity. Because behind every exaggeration lies the same emotion, wonder. And wonder, even misplaced, is a form of reverence. We might not understand the universe, but at least we still know how to be amazed by it. That is what separates cynicism from curiosity. Cynicism looks at mystery and says, Nonsense. Curiosity looks at mystery and says, not yet. In that tiny difference between rejection and patience lies the heartbeat of science itself. ATLAS tests that patience. Its data contradicts models. Its behavior mocks predictions. Its chemistry breaks rules, and yet, instead of discouraging us, it draws us closer, because every irregularity is a doorway. Every impossibility is an invitation, and maybe that's the real message hidden in all this strangeness. Not that we're being contacted, or warned, or tested, but that the universe is urging us to keep asking, to remain humble in the face of wonder, to accept that uncertainty isn't a flaw, it's a feature. As one astrophysicist put it, the cosmos doesn't owe us explanations, but it keeps offering questions. That's its kindness. So we listen through telescopes, through algorithms, through the silent glow of comets. We measure, we speculate, we dream. And in those dreams we sometimes glimpse the deeper truth that what we're really studying is ourselves. The universe is vast, ancient and impartial, but our response to it, our curiosity, our awe, our relentless pursuit of meaning, that's what makes it alive. Atlas is not alive in the biological sense, but it makes us feel alive, and maybe that's enough. Because to wonder, to truly wonder, is the closest thing to breathing in eternity. By the time you hear this, Tri-Atlas will already be gone. Not gone in the way things die, but in the way light fades into distance. Its trajectory has carried it around the sun and back toward the edge of darkness, where the solar wind thins and our star's influence dissolves into interstellar night. For a few short months, we shared its path, we pointed our instruments, whispered our theories, and watched it breathe against the silence. And now, like a guest who stayed just long enough to remind us how vast the world is, it slips quietly away. It will not return. Its orbit is open, hyperbolic, unbound, eternal. It will cross the outer planets, pass beyond Neptune, and vanish into the thin cloud of dust and rock that marks the solar frontier. Then it will keep going past the heliopause into the true dark, the interstellar medium, where the sun is only another star. Perhaps it will drift for another billion years before it passes near a new sun. Perhaps it will never be seen again, and yet its story doesn't end here, for even as it recedes, your Atlas leaves behind something precious, not debris or dust, but understanding. Every spectrum recorded, every emission line catalogued, every faint pulse of light absorbed by a telescope's mirror, all of it becomes part of humanity's growing memory of the cosmos. Didn't just watch a comet, we met a messenger from another time. It taught us that water can flow in the cold, that metals can unbind, that carbon can dominate where life may not exist. It showed us that even chemistry, that most stubborn of laws, can be rewritten by distance and time. And, perhaps without meaning to, it reminded us of something more profound, that the universe is still capable of surprise. That reminder is not small. In an age where our instruments map the sky in exquisite detail, where supercomputers predict planetary formation to decimal precision, surprise has become rare. We have grown accustomed to certainty. But 3i Atlas broke that comfort. It whispered that even in a cosmos we think we understand, there are still places where the rules bend. There is humility in that, a soft, necessary humility. For centuries, We've looked outward to measure how big the universe is. Perhaps now it's time to look inward and measure how small we still are within it. As the comet recedes, its green glow fades into faint neutrality, the color of dust returning to shadow. But if you could stand somewhere out there, billions of kilometers away, and look back at our sun, you might see a brief glint, a reflection, a reminder that even the smallest traveler can carry light across eternity. Astronomers sometimes describe such objects as time capsules, but maybe that's too clinical a word. A capsule holds something to be opened later. 3i Atlas held something to be remembered now. It carried chemistry from an older galaxy, a time before our sun existed, before Earth had oceans, before language had ever been spoken, and in its brief passing, it offered that history to us, written not in ink, but in the dance of molecules illuminated by a distant star. What a strange exchange that is, a message travelling for billions of years, decoded in an instant, then lost again to the dark. It's almost as if the universe writes poetry that only exists while it's being read, and maybe that's all 3i Atlas ever wanted to be, a single verse in that cosmic poem. There's a tendency in science to see discovery as conquest, to think we capture knowledge, but this comet reminds us that the truest form of knowing is fleeting. You cannot hold a beam of light. You can only witness it. Understanding is not possession, it's participation. For a brief window of time, humanity participated in 3i Atlas's story. We listened, we measured, we imagined, and in doing so, we became part of its journey. That's what makes this moment sacred, not the data, but the connection, the sense that across billions of years and trillions of kilometers, something from another world brushed against our awareness and left us changed. Perhaps that's what the word messenger truly means. Not a being that speaks, but an event that transforms. Long after its light has faded, 3i Atlas will remain in our archives and our imaginations. It will live in textbooks and simulations, in artists' paintings and philosophers' metaphors. It will continue to whisper in the minds of those who study it, reshaping how we think about matter, motion, and the fragile border between the known and the unknowable. And somewhere, perhaps in another century, when the next interstellar visitor arrives at 4i or 5i, or something beyond names, someone will remember this one. They'll compare spectra, trace orbits, and notice patterns, and they'll realize that the galaxy is not silent at all. It speaks slowly, object by object, messenger by messenger. Each one a syllable in an infinite language. Each one a reminder that creation never ended. It's still happening, everywhere, always. Standing here under the same night sky, we are part of that language too. We observe, we record, we feel. Our curiosity itself becomes a form of communication. The universe trying to understand itself through our eyes. So when the last faint echo of 3i Atlas fades from the sensors and our telescopes turn elsewhere, we should not mourn its departure, because everything it carried is still here, in our instruments, in our questions, in the quiet awe it left behind. We are its continuation. In the grand silence of space, it takes both a traveler and an observer to create meaning. A comet drifts through emptiness, and somewhere a mind looks up, and suddenly the emptiness becomes story. That's the miracle, that's the secret thread connecting matter and consciousness. Observation turning existence into experience. So maybe 3i Atlas was never just an object. Maybe it was a reflection of how the universe learns about itself through us. And now that it's gone, that lesson remains. In time, our sun will fade too. Our planets will drift. Everything we've ever built will return to dust and silence. But for a brief and luminous interval, we have participated in awareness. The universe, for a moment, looking back at its own reflection. If 3i Atlas could speak, maybe it would say nothing. Maybe it would simply continue drifting, patient, eternal, trusting that its journey alone is enough of a message. And perhaps that's all the cosmos ever does, send silent travelers across the dark, trusting that somewhere someone will see them. And remember, because memory, not matter, is what truly resists the cold. And so, as we watch its green fire fade, we whisper our gratitude. Thank you, traveler, for reminding us that even the smallest flicker of curiosity can bridge the abyss, for proving that distance cannot silence connection, for carrying, across billions of years, a story that ends here, in our eyes, in our hearts and in our sleep. Sleep well. Messenger, you've reached us, and we'll keep listening.